Here we have a SAT math problem. Okay, let's go to the question. The circle in the figure above has center O and radius 10. If line segment BC is perpendicular to line segment AD, what is the length of the line segment AC? Okay, in the given figure, we have to find the length of this line segment AC. And since O is the center, this line segment OA represents a radius, and the radius is given over here, that is 10. Now our aim is to find the length of this line segment OC. Once I get the length of this line segment OC, we can add the radius 10 and the length of this line segment OC to get the length of the line segment AC over here. Okay, how do you have to get the length of this line segment OC? Okay, here let me draw a line segment from the center of the circle O to the point B on the circle over here. Actually, it represents the radius because it connects a center and a point on the circle. OB represents a radius. Already we know that OA represents a radius. Now, let's consider the triangle we have over here, OAB. So, this is an isosceles triangle because the two sides are equal in length. OA and OB, both of them are radius to the circle. Okay, in an isosceles triangle, the two interior angles which are opposite to the sides of equal length must be equal in measure. So this interior angle and this interior angle are opposite to the sides of equal length. So they must be equal. Already we know the measure of this interior angle 30 degrees, then the measure of this interior angle also must be 30 degrees. Then what is the measure of this angle? For that we have to add these two interior angles and we have to subtract the result from the 180 degrees. Because in any triangle, the three interior angles will add up to 180 degrees. When I add them, I am getting 60 degrees. When I subtract 60 from 180, I am getting 120. That is the measure of this angle is 120 degrees. And also the length of this line segment OB is 10. That is the radius of the circle. Let me mark it over here. Okay, now let's consider the angle measure we have over here 120 degrees. Here we have 120. What is the measure of this angle? It has to be 60 because here we have the straight angle. The straight angle always measures 180 degrees. When this part is 120, then this part has to be 60 degrees. And what is the measure of the interior angle over here in this triangle OBC over here? It has to be 30 because in any triangle, the three interior angles will add up to 180 degrees. Here we have 60 and here we have 90 and it must be 30 so that when I add these interior angles, they will add up to 180 degrees. Now, it is a right triangle. I mean, OBC is a right triangle because we have a right angle over here and also it is a special right triangle. That is a 30, 60, 90 special right triangle. In 30, 60, 90 special right triangle, the side which is opposite to the smallest angle measured 30 degree is considered to be the shortest leg. So this OC is the shortest leg and usually we assume X as the length of the shortest leg of 30, 60, 90 special right triangle. Then to get the length of the next longer leg BC that is opposite to 60 degree angle measure, we have to multiply the length of the shortest leg X by square root of 3. Then it is X times square root of 3. And in this right triangle OBC, this OB is the hypotenuse because it is opposite to the right angle. Okay, so here to get the length of this hypotenuse OB, we have to multiply the length of the shortest leg by 2. Then 2x is the length of this OB. So always we have to remember this stuff in 30, 60, 90 special right triangle. Okay, here I got the length of the hypotenuse OB in terms of x, that is 2x. But already we have the length for this line segment OB, that is the radius of the circle, that is 10. So this 2x and 10 must be equal. So that I am getting 2x equals to 10. When I divide both sides of this equation by 2, I am getting x equals to 5. Okay, here I got the value of x, that is 5. We can replace this x by 5. Okay, here I got the length of this line segment OC, that is 5. Already we have the length of this line segment AO, that is radius, that is 10. Our aim is to get the length of the line segment AC. For that we have to add this 10 and 5. 10 positive, 5 equals to 15. Therefore, the length of the line segment AC is 15 units.